Algebra Unit 4, Lesson 2, Notes 2, Solving One-Step Inequalities. Set builder notation. A more concise way of writing a solution set is to use set builder notation. An example of set builder notation is the following, which is read: the set of all x such that x is greater than 0. So again, the brackets tell us the set of all x such that x is greater than 0. Solving inequalities by addition or subtraction. If the same number is added or subtracted from each side of an inequality, the resulting inequality is also true. Solve the following inequalities, write the solution in set builder notation, and graph the solution. So letter A. So to solve this one-step inequality, we're going to solve it just like an equation. We're going to add 12 to both sides, and we get x, bring down the symbol, is greater than or equal to 20. The way we write that, x such that x is greater than or equal to 20. And make sure you use the curly brackets, not regular brackets or parentheses. They have to be specifically those brackets because those tell us it's a set. And when we graph this, we have 3 lines, 20 in the middle, 1 below, 1 above. It is a closed circle on 20. And we would shade x values greater than or equal to 20, which means to the right. Let's look at letter B. We need to get g by itself, so subtract 8 from both sides. Negative 14 minus 8 is negative 22. Greater than or equal to, greater than or equal to g. There's the eraser. There we go. Those canceled. Okay. So our set builder notation would be g such that. Now, I need to put my variable first. And just follow what the symbol is doing. It's pointing towards the negative 22. It's opening, I should say, towards the negative 22. So it needs to stay that way. So if this were negative 22, it needs to open towards that negative 22. So it's really read, g is less than or equal to negative 22. So let's go ahead and graph it, put our numbers down. It is again a closed circle. Closed circle on negative 22. And I want g values less than that, so I will shade to the left. Let's go down to D. We're going to subtract 1/3 from each side. And we get A is greater than. 2/3 minus 1/3 is 1/3. So our set builder notation is the set of all A such that A is greater than 1/3. Let's go ahead and plot it. I'm going to put 1/3, and I'll count by thirds, might as well. This would be 2/3, and 1/3 less would be 0. This time it's going to be an open circle on 1/3, and I want A values bigger than 1/3, which means I shade to the right. Letter E. M plus 19 is less than 56. So let's go ahead and subtract 19 from both sides. We get M is less than. 56 minus 19 is 37. Our set builder notation is the set of all M such that M is less than 37. And let's go ahead and graph it. 37 in the middle, 1 below, 1 above. It is an open circle on 37, and we want m values less than that. So we are going to shade to the left. Solving inequalities by multiplication or division. If the same number is multiplied to or divided from each side of an inequality, the resulting inequality is also true. If you multiply or divide by a negative number, the inequality symbol changes directions. Let me go ahead and try and prove that to you. So if you look at this example here, let's say I wanted to rearrange it so I didn't have to multiply or divide by a negative. Well, first thing I could do is add 3x to both sides. Well, negative 3x and 3x add to be 0 is less than 27 plus 3x. And let me move our number over by subtracting 27. 0 minus 27 is negative 27 is less than 3x. Divide by 3, we get negative 9 is less than x. Now in this situation, I did not change my symbol. But that's a lot of work. If we take a look over here and we use our shortcut, starting again with negative 3x is less than 27. If we divide by negative 3 on both sides, we have to change the symbol. So we still get negative 9 and we have our x, but this time our less than symbol becomes greater than. And if you notice, it's exactly what we would have gotten had we done this the long way. So this is a shortcut method, but you must remember that when you multiply or divide by a negative number, you must flip the inequality symbol. Let's do a couple together. Let's look at letter A. Solve the following inequalities, write the solution in set builder notation, and graph the solution. So we're going to divide by negative 4 on both sides. They cancel out here. Negative 4 divided by negative 4 is positive 1, but I have to flip the symbol, so it becomes less than or equal to 1. Our set builder notation is the set of all m, such that m is less than or equal to 1. And let's go ahead and graph. 0, 1, 2. We do have a closed circle on m, or on 1, I mean. Okay, and we want m values less than 1, so we shade to the left. Letter B. Negative 3 over 7r is less than 21. When we have a fraction, we need to multiply by its reciprocal. Its reciprocal is negative 7/3. So those cancel. I have r, and 21 times negative 7/3 winds up being negative 49. And again, I need to flip the symbol, so it becomes r is greater than negative 49. So the set of all r, such that r is greater than negative 49. Let's graph. Negative 49 in the middle. Down 1, up 1. It is an open circle, and I want r values greater than negative 49, which means I shade to the right. Our directions are a little bit different down here. It says circle all the numbers in each box that are a solution to each inequality. Okay, we're still going to solve it. We're going to divide by negative 0.5 to get q by itself. 16 divided by negative 0.5 is positive 32. We have to flip that symbol because we divided by a negative. So 32 is less than q. So if we were to graph this, 32, then 31 and 33. I know it's an open circle on 32, and I want q values greater than 32. I like to read my inequalities by saying the variable first. It helps me when I'm drawing the graph. So q values greater than 32 would be to the right. Okay, and we need to circle the ones that in the box. So 28 is not greater, 30 is not greater, 32 is not greater, 34 and 36 are both greater. Let's look down on letter E here. Okay, to get rid of a fraction, 1/5 m is greater than or equal to 1/3. To get rid of a fraction, we're going to multiply by its reciprocal, which is 5/1. And we get m over here and 5/3 over here. We did not multiply by a negative number, so we are actually going to keep that symbol the same. We have 5/3 in the middle. If I went up one, that would be 6/3, but 6/3 is the same as 2. If I went down one, that would be 4/3, which can't reduce, so we'll leave it as 4/3. It is a closed circle on 5/3. And I want m values greater than or equal to that. So when we circle, we want m values greater than or equal to. So if it's or equal to, I know that 5/3 is one of them, and 2. Go ahead and finish the rest on your own.